Welcome everyone. I'm going to talk about Raku syntax I miss in other languages. And um, in particular, I'm going to focus on features that help with making code more self-describing. And in my experience, doing so is often a matter of how versus what. All code is a description of how it works because a computer can interpret it and computers operate on that level. But good code is also a good description of what it does. Um, and a good example of this would be junctions. Well, what are junctions? Junctions are operations that are distributive until they do a Boolean operation. Well, what does that mean? Distributive means that any a, b is bigger than 2 is equivalent to any a is bigger than 2, b is bigger than 2. And it is distributive over almost any operation in the language. So for example, hash any keys is identical to any hash keys. Distributive means that the order of operations doesn't actually matter for the end result. It's just a matter of which one is more expressive or useful in this situation. The other half of it is the Boolean operation, because the one thing that a junction is not, well, there are a few more, but the one major thing that is not distributive over is boolification. On boolification, the Boolean operation of the junction, which is any, all, one, or none, will be performed on the bag of values that it contains, and that Boolean is returned. And in my experience, there are two ways of using junctions that I call right side and left side. I made these terms up myself. No one else uses them, but I think they're really good at describing how to use them. I think all of you have written code like this, right? If value is 1, or value is 2, or value is 5. This is clear enough code, but it's very repetitive, and well, none of us programmers like repetition. So junctions allow you to write if value is any of 1, 2, or 5. And I call this a right-hand junction because it tends to occur on the right side of a comparison. You can also write this using the infix operator for any. Value is 1 or 2 or 5, which for right-hand side I tend to prefer, whereas for left-hand side you tend to use the functional form. A left side junction is more loop-like and tends to combine with a lot more operations. For example, imagine you have a list and you want to know, is any of these values larger than 42? In a lesser programming language, you would write a loop like this, and I'm sure you've all read that, and this is working perfectly fine, but it's a lot of code for something that is very simple. There's a lot of how in here that's obfuscating the what. In Perl, you probably use list any, and you would write it like this: if any $_ bigger than 2 values, which is a lot better, because at least it is a single statement, a single expression. However, it still has a bit of an awkward order because the values is at the end when it's actually a very important thing that you kind of want in the beginning. Using junctions, you can write it like this: if any of these values is bigger than 42. This very much self-describes what it's doing. And I think junctions are a very powerful concept of writing code that in this way is very self-describing. But you can't only use it with comparisons. You can, for example, also say if one of these values is prime. It's immediately clear what you're trying to achieve and how it works, and the how behind the curtains doesn't really matter. Or likewise, you can say if all of these values are divisible by 3. The divisibility operator is another small, nice Raku feature that I do kind of miss in other languages. So yes, junctions are great. Another great feature that I find makes my Raku code a lot more readable is named arguments. And unlike most of the features that I'm highlighting here, named arguments are not necessarily uncommon. There are a bunch of other languages that also have them, but Raku tends to do them differently in ways that I find are very helpful. And the basic syntax for it is usually colon, name, and then between parentheses, the value, or the fat arrow syntax, which is similar to what some of you may know from Perl. And this is similar enough to other languages. And in usage, and in declaration, you use the same colon, which has a very nice symmetry to it. So here you have a named argument foo, and you pass it on. And this way you can pass a bit of extra information in this function call. But that's not the only reason why this works so well on Raku, because in a lot of languages, named arguments have a lot of noise. There's a lot of words for the information that are passed. Therefore, there are a few shortcuts. In particular, a colon foo has an implicit argument of true. It's a short way of writing colon foo true. And this is very useful because in my experience, Boolean is the most common type of a named argument because named arguments are often used for optional parameters. And likewise, colon exclamation mark foo means passing false. This is another fairly common value to pass as a name argument, therefore it has a shorter form. There's also a slightly shorter form for strings. And what does this look like in practice? Well, this is an example using my module called Pathfinder for finding files. For find files in DIRS, it must be a file, it must have this extension, and it must not be empty. Named arguments allow you to write code in such a way that if you literally say out loud what it says, you know what it does, without having to look up what any of these arguments do. And that's why I'm a big fan of named arguments. But there's another kind of repetition, which tends to happen a lot when you're passing on arguments, and those arguments tend to have the same name, and then you're writing bar twice and bass twice and cos twice. And well, like I said before, repetition is annoying. Therefore, there's another great short form where you write colon dollar foo or bar bass. And this way you don't have to repeat yourself. But this actually has another advantage. Because if you write your code this way, then that's essentially forcing the code base to be very consistent in how it names its arguments. Because there is one way of naming your arguments that is actually working smoother than the others. This is, of course, assuming that the people whose libraries you use give their arguments sensible names. Another favorite feature of mine is pointy blocks. This may be a bit of a surprising choice, but I'll explain why. In Raku, all blocks are callable, all of them. It's just that most of the time you don't need to think about them as such, but they are. And that also means that, in theory, all blocks can take arguments. A good example of this is a for loop. This should be clear enough. For array go to Ellen. The for loop actually doesn't have any special syntax. It's just a for keyword, an expression, and a pointy block. This is very generic syntax that is still very powerful. And I like pointy blocks for 3 different reasons. One of them is ordering. In a traditional ordering, if you want to have an expression but want to store the value of the expression as well, you have to write my if dollar value is foo. That means that the expression foo that belongs with the if is detached from the if. And likewise, this new variable that is conceptually attached to the block is far away from the block. This ordering is wrong. But with pointy blocks, you can swap them around, and the foo that refers to the conditional is actually adjacent to the if, and the value that's conceptually attached to the block is attached to the block. The second reason why I love this is signatures. Signatures are a very powerful feature in Raku that I'm not going to talk much about because I could spend an entire chapter on that too. So for example, in Raku, if you want to loop over two variables at a time, you just give the pointy block two variables. Because for is smart enough to notice that and just do what you expect it to do. And this sort of thing is used in a lot of places. Another very powerful use that I'm personally very fond of is using destructuring. Because naive, like in Perlish Raku, you could write something like this. You check if something matches, and then you unpack $1, $2, whatever. However, you can directly pass that on to the block, and then if this matches, extract these values from the match. You can express that in one go. And I think that's a very powerful concept that translates to a lot of different problems, because it's not only matches that do this well, it's a lot of built-in types that do this well. I mean, an array would map to positional arguments, but you could have like a hash, and those elements of the hash would map to like named arguments of the block, because blocks can also have named arguments. And a lot of types decompose to very sensible values. But the third advantage of this is the regularity. Raku is actually one of the few Algol-derived languages where the syntax of a for loop is actually the same as the syntax of an if statement, except for the keyword itself. I mean, Raku is a language with a lot of keywords, but this complexity is actually managed because the syntax is very predictable, because it keeps being the same. All these keywords are either if-like or else-like. And most of them are if-like. And this really helps in, keeping Raku readable. Another favorite feature of mine, I hope I'm not going too fast, is whatever code. Now, here you see an example with you want to grab to a list of numbers. And here you see the pointy block that I explained before. And this works fine. This is perfectly valid Raku, but it's kind of repetitive in using $n twice. Can we make this more expressive? Well, yes, of course, we can. We can use a default argument $_ here, which already makes it a lot shorter. But can we make it even more expressive? Yes, we can. Using the whatever star, we can just say grep for whatever bigger than 2. This is pretty much as close as you can get to like the minimal possible syntax for like grepping for like some comparison. Of course, it's also always a matter of there's more than one way to do it, and this is not always the right way. Larry Wall's famous for saying easy things should be easy and difficult things should be possible. Whatever code is a brilliant feature for making easy things easy. You shouldn't use it for difficult things should be possible. That's where pointy blocks are great, because they have like they tend to be less confusing if you have like more than one operator. And then there are meta operators. The meta operators sound like a very esoteric subject to most people because it's, well, meta. But actually, it's not that unusual at all. In fact, all of you, all of you have used meta operators before. You see, there's this one very famous class of meta operators known as augmented assignments. In other words, uh, assignment meta operators. A plus is B is a assignment meta operator on plus. Raku is not the first language to have meta operators, it just has a few more than other languages. In particular, the ones that I'm going to focus on, and these are not the only ones, are list-based meta operators. Because in my experience, these add a lot of power to the language and provide a lot of very practical tools. First of all, there's reduction. Reduction meta operators aren't that new at all. They're just fairly uncommon. APL had them, and APL is like 40 or 50 years old, and then most people forgot about it. Sattel had them, and Sattel is not very well known, but it is a very influential language that influenced both Haskell and Python, but somehow reduction operators, not sure about Haskell, didn't become popular. A reduction operator essentially does a reduce, or also known as a fold, with an infix operator. It takes a list of values and reduces that to one value. In particular, it's smart enough to respect the associativity of an operator. If it's left associative, which is almost all of them to be honest, it will do a left fold from left to right. If it's right associative, it will go from right to left. There's chain associative and will also correctly handle that. So without reduction meta operators, you would do something like this. My sum is reduce A plus B over a list. But with a reduction meta operator, you can just use that. You can just use this. You can put the operator between square brackets, and it will apply this operator to the entire list and return the resulting value. And this is incredibly expressive. And it's also actually very useful for a lot of very common operations. For example, I just showed you sum can be expressed as a meta operator. The product of a list can be expressed as a meta operator. Joining a bunch of strings can be expressed as a meta operator. These are all very common operations, and their use is kind of only limited by the fact that some of these are already built-ins anyway because they're so common. But there are a lot more interesting uses for the reduction meta operator. For example, if you want to know, are all these values equal? Are these values sorted? In most languages, that requires multiple statements to actually figure that out if you don't have a function for it already. In Raku, you can just express that in 3 characters. Likewise, you can say you can apply the OR operator on an entire list to get the first true value. It'll just do that for you. Reduction operators are very, very pragmatic and very useful operators that have a lot of surprising uses once you actually see them. Another favorite is the zip meta operator. Now, whereas the reduction takes a list and reduces that to one scalar value, a zip operator takes 2 or more lists and transforms that into a new list. That's what essentially all zip operators do. They just differ in how they make the new list. For example, you can say 1, 2, 3, zip plus 30, 20, 10, and then you get 31, 22, and 13. It applies this operation on like the first element of both lists, the second element of both lists, the third element of both lists. The most common use of this, probably, at least in my experience, is Z comma. And in fact, Z comma is so common that the Z operator without any specified operator will do that. And why is it so useful? Because this allows you to loop over two lists at the same time. For situations where that are too complicated for just using a single operator. And here again, you see a pointy block used to decompose these elements. This creates a list of 2-element lists, and you use a pointy block to decompose the elements of those new lists into 2 new scalar values. This is incredibly useful. And in a lot of languages, it is really kind of ugly. You have to loop over the index of both of them. And here you can just say, I want to loop over A and B at the same time. Thank you very much. Another good use of this is you take a list of keys, you take a list of values, combine them into a hash. Also, of course, zip operators chain. I mean, I used examples of like 2 lists here, but you can also use 3 or 4 or 5 or 6 or however many you want. That, of course, also means that you can reduce a zip operator. And in fact, reducing a zip operator is a useful thing to do, because what this does is transpose a list of lists in 3 characters. The third meta operator I'm going to talk about is a cross product. Now, a cross product permutes 2 lists. That means it takes an operator, it loops over one list and then over the other and then the first list again, and it produces all possible combinations of those 2 or more lists. Let's take, for example, this example. You have a list 3, 9 and a list 2 and 10, and you want to take all of the possible sums. In most languages, you would have to write this. This is a lot of code for a fairly simple thing. In Raku, you can just say 3, 9 cross plus 2, 10, and this will return the list for you, all 4 values. This is a very expressive way of saying, this is what I want, and you don't have to write all this code of how you get there. I think that's very expressive. Surprisingly, perhaps, in my experience, the most useful thing you can do with the cross operator actually only involves a list on one of the 2 sides. Because, for example, here, if you have a list and you want to prefix a value to all elements of a list, you can use a cross operator. And the cross operator will just see that as a list of 1 element and do its thing. Again, this is so much. This is way easier than in any other language that I've ever seen. The last meta operator that I want to talk about is hypers. The previous 3 examples were all meta operators on infix operators. Hypers also works on prefix and postfix operators, which is actually their most interesting use. You can kind of use hyper to implement like the others, but that gets really confusing. For example, you can say lists hyper.apps, and it's the equivalent of, say, of mapping all values and getting their absolute value. It's the same thing, except less typing, more expressive. It works on prefix operators. It works with post-circumfix operators. This is one of the more useful ones, because actually I tend to do this sort of thing a lot, where I'm like, I have some list or an object or whatever, and I want one thing out of all of them. 1 extra character, and you can do that for all of them. But let me give you an example of how to combine these by computing a Euclidean distance. When you're computing a Euclidean distance, you're taking the distance for Euclidean distance is the distance over multiple dimensions, the complete distance. For example, when you're computing this, you want to first compute the distance for every different dimension, which you can do using a zip operator. Then you want to square them. You can do this using a hyper operator. Then you want to sum them, which you do using a reduce operator, and then you square them. This is a very practical algorithm that's, for example, used in like voting advice software. And you can implement this in Raku using a single expression. I think that's really powerful, and it can be confusing. I mean, I imagine if you've never programmed Raku before, you're like, what's happening here? But if you actually know these concepts, then you can express things way more cleanly, and like literally, this is the entire algorithm described in one operator per step. And lastly, I want to talk about smartmatch. Now, some of you may be thinking, really, smartmatch, what are you smoking? Now, and if you're thinking that, then you're probably more of a Perl programmer than a Raku programmer, because in Perl it tends to have a bunch of issues, but in Raku it tends to work really, really nicely. Because what smartmatch really does in practice is answer the question, is a value part of this set of value? Is it this kind of value? And in Raku, almost all built-in values are actually smart matchable. So you can use them to answer the question, is this value like this other value? And in Perl is mainly known for its use in when, but in Raku, I would claim that the canonical use of smart match is actually grep. Grep will smart match its values against its arguments. For example, we had the whatever code before becomes a small code object which compares, is this bigger than 2? But you can likewise say smart match against a string, and then it will check which of these values are string-wise equivalent to the string foo. You can compare the numbers, and it will do exactly what you expect it to do. You can match against a type object, and it will do exactly what you expect it to do. You can match it against a regex, and it'll do exactly what you expect it to do. You can match it against a range, and it'll do exactly what you expect it to do. You can match it against a pair, and it will not do what you expect it to do, but it will do something very, very useful nonetheless. It will call that method on the object and match and gather any value but where that method returns true. For example, grep :prime will give you all the prime numbers in a list. And of course, we go back to one of my favorite features in Raku ever, junctions. Junctions are just made for smart matching. For example, if you want a prime number that contains 2 consecutive 2s, you can just say is prime and matches 2, 2. This will just work. You can combine any smart matchable object using any other smart matchable object using junctions. One of the more useful ones actually here is none. You can negate any smart match by putting it in a none. This will return all values that do not match 2, 2. But how do you use this? Well, again, I'm using an example from my Pathfinder module, find dirs. Find in dirs with the extension RakuMod or PM0, with a size bigger than a kilobyte, with the depth 3 to 5 that contains this regex. This is code that I don't have to comment what it's doing here, because it's literally describing out loud what it is doing. And I think that's amazing, because I haven't seen anything in any other language that allows me to be this literal about what I'm trying to search for. You usually have to write like the code out explicitly. Thank you. Any questions? I think I went a bit fast. No questions?
Lacking any other questions then. This one could go on for hours, so I'll suggest you should probably keep your answer to about 2 minutes. But to what extent do you think that some of these ideas could be borrowed back into Perl, provided we don't do another 510 with the whole smartmatch in Perl problem?
Yeah, it depends. Some of these features are more easily done than others. Like junctions are like a very deep feature that like full junctions is actually very difficult, but some of their some of their functionality is actually quite doable. Like right-hand junctions are actually fairly easy to implement. It's the left side ones that get really complicated, because right side is basically you can do that using operator overloading and whatever.
So there's sort of 2 layers to my question, because most of the features that you're suggesting, things like the junctions and the smartmatch and so on, are syntax that is like we couldn't, for instance, trivially just have the pipe operator in Perl to do these junctions, because the pipe operator already means numerical bitwise OR. So we'd have to find a new way to spell it, but the actual functionality is fairly easy to implement with just another spelling. But things like the pointy blocks are a kind of a much harder thing to do.
Yes.
Conceptually, like it's not just a matter of spelling it. I feel it's different on a different level.
Yes, I would agree. It's all a matter of it varies a lot per feature, really. I mean, I would really like to see some of those meta operators also in Perl, because I think a bunch of them are doable. Not with the same syntax, but
I mean, not to spoil the surprise too much, but I've just implemented the divides operator while I was watching that talk. I could have done that now. But some of the meta ones are a little bit tricky for the spelling of them. But I mean, I wonder whether it's worth the Perl side of things, just sitting down and going through that list and thinking, in practice, could we import some of these, but try and do it in a safer way than we did last time with smartmatch.
Yes, I mean the problem in 510 is that they really try to transplant features one-on-one without doing like a translation from Raku to Perl, and then that got very confusing. But yes, some of these features could definitely be ported. Yes.
Yeah.
I think the meta operators, or at least the first 3, would be fairly high on that list.
Yeah, I don't know about timing here. I don't want to spill over timing into a huge conversation, but I mean, I've been trying really hard. The square brackets, I think, are not going to fly in Perl, but I've been trying really hard. If we get rid of the readline operator and we get rid of glob, then suddenly we can get angle brackets back, and I think that actually we can do a lot by just using the angle brackets rather than square brackets, and there may be some potential there.
Maybe, but
it's non-trivial, but it might be doable.
I suspect that we're gonna have to find find our very own syntax for these concepts.
There's been a lot of chatter, so I don't know how we would summarize that.
Yeah, I'm just seeing that now, and it's like a lot of chatter. I guess I'll look at that later.
Very briefly, is there syntax that you miss when you're working in Raku from other languages?
Because
we'll add it. We will.
Yes, probably. I can't think of anything right now. Because I think pretty much anything has been added already.
Thank you. Oh, to summarize the chat, there's a whole lot of complimentary and interesting discussion, but there was a question of why you didn't cover laziness. Maybe because you don't consider it syntax, or we don't know why.
Yes, well, I wasn't expecting to have like this much time left, but nerves made me go a bit faster than I would ordinarily go. Lazy lists, yes, are a very useful feature too, but they're less, I'm kind of focusing on syntax here, and lazy lists are more on the semantic side, I would say.
Leon, you should use the 3 dots in the chat to save your chat so you can browse it later.
Mm-hmm. Yes, I already did so.
Okay.
Any more questions?
Great talk.
Yes, sir.
Indeed.
Yeah.
Well, if I have spare time, then there was one I don't have slides for it, but there's one feature that I really like that I thought I wouldn't have time for, but I'm just going to describe it.
Okay.
In Raku, it is legal to use a dash as part of a name, which is very common in Lisp-derived languages, but in Algol-derived languages, it is not. And I think this is great because, frankly, no one ever used an underscore unless computer systems forced them to use underscores. Whereas dashes are actually part of natural languages. And Raku just decided we're gonna allow this because given sigils, there are very few ambiguous cases. And in the odd ambiguous case, we'll just use white space to disambiguate them. Which sounds kind of complicated, but in practice, it turns out to always work exactly as you expect it to do. Which is a tiny, tiny, tiny feature, but I really appreciate it because dashes just look so much prettier than underscores.
Also apostrophes, which are
Yes,
not
also
quite as handy, but very
I've
useful
never
on
been
rare
tempted to
occasions.
use them like in real code, whereas I use dashes literally all the time.
Leon, are you talking about an underscore or a dash or a hyphen?
Hmm?
Are you talking about an underscore or a hyphen?
A hyphen.
Thank you.
Yeah, the only time I've been tempted with apostrophes is to demonstrate possession, which does occasionally come up.
Yeah, it's a cute trick, but I'm not very tempted to use it. Whereas like hyphens all the time, wherever I would use an underscore in any other language, I use a hyphen in Raku.
And what about Unicode characters as operators?
I use them, but only some of them, because some of them are like relatively easy to type and others are fairly difficult. And well, like some operators are like for hyper, I will definitely use the French quotes. But do I use other Unicode operators? Not that many, I think.
Regardless, I'm still for the idea of deprecating or killing the use of apostrophe as a package separator.
Yes.
That will break the Acme don't module, though.
Don't care.
It will break isn't.
Good.
It has more. Not that that is a good idea, but it exists.
Yeah, some of the Perl ideas I have might break the is function, though. That's the problem.
There's that.